Good afternoon, Fancy Meat Computers. How's everybody doing today? I hope we get more than 3 people coming to this lecture. Otherwise, it's going to be a pretty short lecture. Tired, very tired, says Mark. Yeah, I feel that. Yeah. Doing Project 3. Yes! So, yeah. This is technically speaking a review session for the exam, but since you've got Project 3 due today, if you wanna ask questions about Project 3, I'll allow it. But I'm gonna give priority to the to questions about the exam. Okay? But yeah. Yeah. I suppose I should look at the Piazza questions, eh? See if there's anything. Bit of a backlog. So there's only one question from Piazza that's kind of like relevant to the exam. That's, hi, I wonder if we have Haskell implementation in the final exam. And if you do, it certainly won't be anything at the scale of one of the projects. But yeah, I'm not ruling it out. Yeah. Fix 1 test case, failed on 2 more. That's programming for you. Let's take a shot. What's on the exam? Be very specific. Like, exact question wording would be great. Yeah, okay. No. But, you know, exam coverage is a fair question. So, I guess I'll just, I'll go through that to get us started off. It's all of the major topics, essentially. So, like, knowing how to do a grammar in EBNF, knowing how to do semantics, using inference rules, knowing how to do a proof using induction / or ampersand case analysis, That's been a major thing we've been doing. In terms of like specific code constructs, like language features up to and including exceptions. You should look up the Sinnerman flowchart I did for it and do an eBNF for it. That would be take you a decent amount of time. Yeah, I don't want like eBNF to be like the whole exam though, you know, because we did it in like week 2. Stuff in the extended or advanced topics and type theory, I'm not going to cover any of that on the exam, as was our pact. A small Haskell implementation of something. Yeah. So that's basically, you know, these are the topics that you're looking at, basically. I want Haskell stuff, honestly. More A2 stuff. More A2 style. Yeah. I mean, yeah. Any questions? Any requests for clarification? Like I said, if there is no questions, I'm just going to assume that everybody is, like, everybody's good, you know? Which I know isn't the case because nobody's been coming to class, but, you know, the people who are not got here are also the people who don't come to class, presumably, so, tell me we won't have to write a recursive lambda function up to this input like Fibonacci. No, that would be too long. Could the slides for topic 14 be updated on Avenue? I will update them when I have them complete. I want to throw a few more slides on just to sort of round off the topic. So yeah, I'll update that when I get those slides finished off. Yeah, I'm it's like the reason that A4 had a bunch of like lambdas, like compute X lambda expression, was that the purpose of that was so that people would get the experience of having done that calculation a bunch. It's like a math drill. You don't put math drill questions, like you don't do math drills on an exam. The test is to test. It's not to practice. But yeah, I liked making the Fibonacci function, but writing out the application was tedious. Yes. Should not type check, but why? I don't know why that... I think that must be related to the type checker you're currently working on, and since I can't see your screen. Yeah. Yeah, you know, let's cover A9's proofs, since no one is asking about anything. I want to know what the intended solution likes, and we definitely won't have it by the exam. Yeah, fair enough. Let's see here. So, assignment 9. There we go, assignment 9. So, I guess I'll put it in like point form here. So, that is sadly the only points I took away on the course review of this course. Untimely assignment feedback. I hated doing it because I know why, but it still happened. Yeah, that's completely fair. Completely fair. Like, there's a lot of things that I could say about it that I'm not going to. Let's just leave it at that. But yeah, I am. Trust me, I'm not a noob. You know, I know that the assignment feedback has not been timely. I am fully and functionally aware of this, but you know, sort of factors beyond my control contributed to the problem, and then further contributed to the problem, and then it came a huge mess, and then, you know, by like 2/3 of the way through the course, the mess started to alleviate, but that by then it was too late to really be able to get timely feedback for the rest of the course, unless you wanted to like skip the feedback for assignment 7 or something. But anyway, assignment 9. So, proof of progress for reference semantics, right? So number 1, we needed the new canonical forms, right? So, it's very, very simple, right? The new... I have had people ask me about posting my assignments for A8 to 10, but we're probably not going to have grades back by the exam. Is it cool to upload them since I think everyone's done theirs by now? Let me just... Give me a moment to check to see if all of the extensions have expired on assignment 10, because I think assignment 10 there might still be open ones. Accommodations, though. Let's see. Yeah, I got a 7-day open accommodation. Well, is that open, though? No, assignment 10 was due not this last Sunday, but the Sunday before. So yeah, it should be good. It's not legal for me to give an extension more than 7 days, so... Oh, was it, like, oh my god, let me see here. When did I set the due date again? Even I'm forgetting. A10 was due November 29th, which was last Monday. So this Monday, all of the accommodations in MSAFs will be cleared because they can't go more than a week even for an accommodation. So yeah, you're clear. You're clear. Good. So, I'll talk you through the solution for this assignment. All right. So, number one, new canonical forms, right? The issue with posting assignment solutions publicly is the answers are now out there and the questions become non-repeatable. Yeah. Well, you know, do we reuse solutions for what, or do we reuse questions on the assignments on 1MD3 from year to year or from semester to semester? You know, like, yeah. I'm aware of the problems inherent in the system, and the next time I teach this course, I'll change up the assignments somewhat. But yeah. So anyway, and besides, if I these aren't the public the solutions that Ben has been putting out there are just his solutions. I'm not verifying that they're correct, right? So anyway, let's talk about the proof of progress. Number one, new canonical forms. So it's very easy. If v is a value of type ref t, that's a location term. If v is a value of type unit, then it's a unit. Then it is the unit term with a lowercase u. It asks specifically in the question for an acknowledgement that we only need to prove progress for the new terms that we've added to the calculus, right? It says, you do not need to reprove parts of the calculus which have not changed, but you do need to state that they haven't changed and that the theorem still holds for them. So it's like, you know, parts of the calculus which are aside from the additions that we're making with reference semantics, progress still holds for them. So there you go. Yeah. Like, Mark, the problem that you're the hole that you're poking is a hole that is poked in every degree program at every secondary institution and post-secondary institution in the whole damn continent, you know? So, you know, while I appreciate it, you know, I appreciate that the system is broken, you know, there's only so much I can do, you know? Because, like, it's just not physically possible to generate new assignments every year or every semester for every course, you know? I know. But, like, you know, in your particular case, Mark, you know, you've been writing a lot of questions for 1MD3 this semester. Considering there are, like, about 100 questions in that course that they have to answer, would you want to regenerate 100 programming problems every 4 months, you know? You'd need a full-time person just doing that, and I mean full-time in the sense of full-time employee. But anyway, so essentially, the way that we prove progress is by case analysis over the new terms, which is one-to-one with the typing derivations. So in my instructor's solution, I actually performed case analysis over the the typing relation itself. So no, the typing relation that's given. Where is it here? Right here, the one that's implied here. If we stripped the question themes, it would be a lot easier, but that isn't the point of the course. Yeah, get a bot to write them for you. Much harder than that's much more difficult. That's much more easily said than done. But actually, we're working on it. We're working on some analysis, some research-oriented analysis tools for Python questions that may inform future like machine learning efforts to automate the generation of assignment questions. Who knows? Who knows what the future will look like 20 years from now? But anyway. I need more money for R&D. That's the answer to that question. So, case analysis over the typing rules that are implicit in the new terms. So, the typing for locations, references, referencing, dereferencing, and assignment. Just use calc check. Get out of here with calc check. Calc check. Blah. Don't blah. So remember what progress is, right? All we're trying to demonstrate is that if it's well typed, it can be evaluated, right? So, or it's a value already. So in the case of locations, they're already values, so case closed. It's trivially true. In the case of references, right? Essentially, from the fact that it's well typed, we immediately derive the term is going to be reference of some subterm T1. T1 is going to have type T1, and T is going to be of type reference T1, right? So there are two cases to consider. Is the subterm a value, or can it be evaluated, right? Because there are essentially, there are two evaluation terms, and because this is determinate, the possibilities are all there. So if T1 can be evaluated to some other term T1 prime, then you can say eref is applicable. And if T1 is a value, then eref v is applicable. So in all cases, an evaluation rule applies, so case closed. For dereferencing, essentially, once again, so with dereferencing, there we go. If we have exclamation point T1, once again, we have one of two cases. Either T1 evaluates to T1 prime, or T1 is a value. If it evaluates to T1 prime, then you apply deref, which is the congruence rule. And if not, you apply deref v, I think it's called. No, deref location. And since it's well typed, you know that the subterm must be a reference type, because otherwise it couldn't be well typed, right? So it's these cases are proved not just with the statement of the evaluation, it's necessary not just to say that you apply this one. It's also necessary, if it's got more than one antecedent, to say the antecedent holds, therefore this evaluation rule applies. So, for all of the congruence rules, this is the only antecedent, so it's going to apply in all cases. The congruence rules are the easy part. it's so with t1 being a value, it's like you have to add by the fact it's well typed ... It must be a location. Therefore, deref applies. Look, applies, etc. Right? Obviously, I'm doing like a quick version. You'd use complete sentences and make it look pretty if you were handing in an assignment. So that's that term taken care of. We then have assignment. So T1 is assigned T2. So for that case, we actually have to break this into 4 subcases, right? Because either T1 is evaluated and T2 is evaluated. T1 is a value and T2 is evaluated. Or T1 evaluates and T2 is a value. Or in fact the case where both of them are values. Right? So, in the first 2 cases, anytime T1 is evaluatable, then you apply E assign 1, right? Anytime T2 is evaluatable, you do E assign 2, but of course, in this case, E assign 1 takes priority because of, congruence and determinacy and all the rest of it. So really the interesting thing is when they're both values. Obviously, when they're both values, we're looking at deref location. Wait, no, wait. Deref location. No. It's like E assign location or something. Whatever the name is. Assign location. Right? So the question is, does E assign location apply? Right? So if you take a look at the slides, references, bop. Yeah, it's just E assign. There we go. So if you take a look at that, it's like, what's the requirement? The requirement is that L, like the first one be an L, right? It doesn't matter what T2 is, essentially, so long as it's a value, which is provided by the case analysis. But if you, you can't assign to something other than a location. So the question is, how do you know this is a location? Well, you can derive that from the fact that it's well typed. If you take a look at the typing rule, there you go. T1 must be of type reference T11 via the inversion lemma that we, or canonical forms lemma. Yes, via the canonical forms lemma, you get that if it's got type T ref T, then it must be a location term, so it's a location term, so the rule applies. Bing, bang, boom, everything has, and that's that final case closed, so you've got all cases being applicable, so everything works out, progress is proved. That's how you prove progress. I think that most people would have found, I don't think progress should have been the difficult one. Of the two, preservation is trickier, because it's trickier for 2 reasons. Number one, it's just like a little bit more complex of a property. And number two, it's got two consequence, so you have to prove both of them, right? So, and I'm not saying this is the only way to argue this, but this is the way that I argue them. I would argue them. So, preservation of reference semantics then. Preservation. Just to remind ourselves what the preservation property is, sort of in general terms. Preservation is, if it's well typed and it's evaluated, what you get out of the evaluation is still well typed. Right? So it's like, so to sort of set this one up, you need some new inversion lemmas. So, for example, you know, considering a location term, if a location term has a type, it must be of type ref, right? Ref t. If a allocation term has a type, it must be of type ref t as well. While you were talking, you told me where my P3 bug was by accident. Fun coincidence, but you just helped me finish A3 with no obvious bugs. Well, there you go. Ha! I'm glad I was useful to at least one of the 5 people who are currently watching. By the way, you 5, you're the stars. You're the superstars. We would not be having a class today if it weren't for you guys. So, so inversion lemmas, etc., right? Once again, acknowledgement needs to be presented that we're only interested in proving preservation for the new terms we've added to the calculus. So that's good, right? That needs to be in there. In this particular case, I decided the easiest way to approach it would be to proceed by case analysis over the forms of t, rather than like proceeding over the typing derivations. Although the typing derivations like need to be there. Like, I don't know. For me, it's easier to organize this one starting with the terms themselves and then saying, you know, there's only one rule that types this term, so if it's well typed, we can still derive the typing information. But yeah. Me, my roommate, a person who I would dare to call a friend, but would likely deny it, and 2 people I have no memory of meeting. The 1MD3 gang, or 1MD3. The 3MI3 gang. 3MI3 gang. That's right. Imagine not knowing how single-step operational semantics work. 3MI3 gang. So. Yeah. Good. I'm not saying it's not possible to have done a, I'm not saying it's not possible to have done a proof by, like, doing case analysis over something else, but for me, doing it over the terms is just, like, the easiest approach to this, so that's how I wrote it in the solution. So we have, once again, the following terms that we have to do a case analysis over. We've got locations, we've got allocation of a term, we've got deallocation of a term, and we've got assignment of one term to another. Right? So, once again, in the case of locations, they're already values, so they can't be evaluated, so they trivially, essentially, pardon me, actually in, in opposition to the way things work for progress, for L to not be evaluatable actually invalidates one of the premises. So what you get is false implies everything, and so a trivial vacuous truth, like this is trivially and vacuously true in the case of a value. So we're, it's like, yeah, vacuously true. So yeah, vacuous as in proven in vacuum, which is to say proven using nothing. It would be so nice if everything you could prove in vacuum. So let's talk about allocation, right? So for allocation, we immediately have the three premises, right? So we know that it's well-typed. We know that it evaluates. And we know that we have a well-typed store, right? Wait, so we need to prove it, go into space to prove that? Yeah, that's right. Yeah. Sorry if I'm springing on you in the 11th hour of the course, but yeah, you can only prove that one in space. It's okay, though, if you send a robot up. Like, if you give your assignment paper to a robot, have that robot do it in space. Then it's fine, so long as the exam paper survives re-entry. So, essentially, we're trying to prove two things, right? So, I thought, like, a good way to approach this problem is to state explicitly what you're trying to prove, right? So, we are trying to prove A, that T prime is well-typed. Whatever this thing evaluates to is well-typed. B, that the resulting store after evaluation is also well-typed. So, from that, I kind of, like, because you have to prove both of these things, it made sense to me to then, like, attack them one at a time. So, for A, so first of all, you can apply the inversion lemma, right? So we know that it's well-typed as ref T1, right? For some type T1, where T1 is typed T1, right? So that's good. I think that the easiest way to do this is case analysis over the possible evaluation relations involved in this particular, like, in the ref T1 case. So I realize that this is a long one because it's like we've got a case analysis within a case analysis, or we've got two case analyses that are nested inside of each other, and like we're trying to prove two things with those case analyses. So it's a bit long, but you know, it is what it is. So essentially, you've got two forms that this guy can take, right? You got eref, so you've got the what do you call it? Congruence rule, and then you've got eref v. So for the congruence rule, so we know that first of all that t evaluates to t1 or to t prime. We also know that t1 evaluates to t1 prime because this is a congruence rule. We get that from the antecedent of the congruence rule, right? So we then know that t1, or t prime, sorry, pardon me, is equal to ref t1 prime, right? We also know that if t1 has type t1, then that implies that t1 prime has type t1 as well, because induction hypothesis, right? That's where you bring in the induction hypothesis. So, given that t1 has type t1, given that t1 prime has type t1, we can say that t1, or sorry, we can say that t prime has type reference t1, which those of you who are quick on the update will notice that ref t1 is actually the same type that that t has, right? I don't think I put that explicitly in this, but yeah, it's like that's the inversion lemma, right? If t has a type, it's or if ref something s has a type, it's ref the type of s. So since t is this guy, it must have type t ref t1. So therefore t1, or like t has the same type as t prime, therefore typing is preserved by evaluation in this case. Fine, good, excellent. Wow, the viewership is like really tanked. I guess people are like, I'll watch this later. So, so in the case of ref v then, we know from ref v that, well, we know that t is equal to ref v1 now instead of t1, so it's a reference of a value. We know that t1 is v1, sure. T prime is a location, right? Mark won't leave, he's too stubborn. Good. Oh, we're back up to 5 people. Must have just been a momentary blip. Or maybe they heard me. We also know that L is not in the domain of mu. And we know that mu prime is equal to the existing mu with the new location mapping to the new v1, because that's how mu is modified. So what we're trying to prove is that there exists some sigma prime such that mu prime is still well typed. And this is like very, like, it's almost trivial, right? It's like, well, if we hypothesize that sigma prime is equal to sigma, regular sigma, concatenated with L mapping to the typing information of v1, which is t1, right? If we hypothesize that as our sigma, then obviously, obviously we have I almost said the word congruence, but we have a special meaning for that in this class. We have a agreement between mu prime and sigma prime, so that works in this case. And now I just realized that I didn't prove. Oh, no, this is B. This is the B part. What am I doing? This bit belongs in B. There we go. That's the argument for B. I'm sorry. B for E, ref V. Right. So, for the evaluation, basically what we're trying to show is that the location will have the same typing as this guy, right? Which, you know, all you have to do is, like, hypothesize the existence of this same sigma prime, right? It's like under this sigma prime, then L does have the typing ref T1, right? Because if you take a look at the typing rule for locations, if L maps to T1 in sigma, then it has type ref T1. So, like, that's the trick, right? That's the big trick of this this existential sigma prime. It's like, because we're only trying to prove the existence of a sigma prime such that these things hold, we can hypothesize intelligently some particular sigma prime which makes it true, and that's good enough for the proof. So if we actually make sigma, if we hypothesize sigma prime as being the actual sigma prime that it would be, then everything holds, right? So that's true. Good. But you have to, like, at the end of this, like, normally with these, you have to apply the typing rule at the end to show that it's like, construct the term T1, construct the term T prime, using the evaluation rule, then use the typing rule to prove that it still has the same type as before, and that's preservation. You know, we're kind of running out of time, so, are there any other questions? Like, I'm not convinced. Like, you should get the flavor of how these go from the first one, and, you know, it's like this, but wash, rinse, repeat for the other two. Once you know how one case works, it's pretty easy to derive the other ones. Any questions? Oh, we have 6 viewers now. That's awesome. Gained a member of the gang. Yes. 3 on my 3 gang. We should have t-shirts made. That's true. It's like me and the boys discussing reference semantics. There you go. I know not all of you are boys. In fact, those of you who are, you know, male are adults, so technically speaking men. But, you know. It's a meme. Do it for the beams. Me and the bourgeois. Bourgeois is an adjective. Bourgeoisie is the noun. It would be me and the bourgeoisie. So I'd just like to report that that career I was starting as a full-time Burger Time streamer has failed. So I'm probably going to keep teaching. It's like, don't quit your day job. Generally good advice. Unless your day job is terrible. I don't know about my French spelling, but in pronunciation I said it right. Well, I can't hear you pronounce it. I think you did spell it right, actually. I would just like to say, French is a language that has too many vowels. There, I said it. We were all thinking it. Well, you could if we were in person. True. But, you know. Yeah, we'll see. We should revert back to Greek. I agree. Greek is an excellent language. Or Latin. Everything. I think that we should go back, like, you know, 500-600 years, and if you want to go to university, all of the classes are in Latin. That's what I think we should do. All the books are in Latin. Everybody speaks Latin. It's just Latin. Latin everything. No questions? Nobody's got any questions? Well. Alright, well, I guess that's the course then. Thank you very much, the 5 of you who saw it through to the very bitter end. We've had our ups and downs in this course. I expect to get, like, roundly abused in the course evaluations for this course. I already, like, took a pretty, I think I took a pretty significant hit on my rate my professor page over this course already. But, you know, I don't have very many reviews on it already, so it's not difficult to have an outsized impact. I think, like, one guy complained that I didn't release the solutions. Gave me 1 star review. So, but yeah, I expect to get roundly chastened on the course evaluations. But I'd just like to say that I've actually, like, really enjoyed putting together this course for you guys. Like, the material itself is, like, I've really enjoyed studying it along with you guys. Like, maybe it's because I'm a geek, but this kind of stuff I just enjoy it. And, you know, you guys who've stuck it out to the end, it's been appreciated. But hopefully we all learned something. My rate my professor is still over 4 stars. I know, but I used to have a perfect score and now I don't anymore. But you know, it is what it is. Those who have still less than 2 need to have their employment reevaluated. Well, you know, I would say something like, you know, research professors aren't employed for their teaching skill generally. you know? Which is, you know, that's like the open secret of the university, you know? But yeah. Anyway, take her easy, folks. Good luck on your exams. And, good night, da-da-da-da, sweet, tight, da-da-da-da, and pleasant dreams to you, do-do-do-do. Here's a wish, da-da-da-da, and a prayer, da-da-da-da, that every dream comes true. And now, till we meet again, adios, da-da-da-da, au revoir, auf Wiedersehen. Good night.